All right, we're going to start with a little review. This is the review day for the Chapter 15 test. And we're going to be doing some solving today. This one is a graph, though. Just graph this one. I'll pause for a second while I give that a try. All right, I would like you to turn your iPad my way, and I will check and see if you did this right. Okay, I'm noticing a lot of kids have this labeled as pi over 2 and negative pi over 2. That's how it starts. That's how tangent starts. And of course, halfway here and here, you got 1 and negative 1, which now changes. Everybody gets this part right. 4 and negative 4. Okay, so, all right, so everybody knows that. But if you didn't change these, then you got something wrong because that's changed the period, right? All right, so what's the formula for that? What's the formula? That's not a formula. Period is equal to... Why are some people saying pi over b and some people saying 2 pi over b? All right, I can tell you no, and I will say it. If it's 2 pi over b is all the other ones, but tangent and cotangent have a period of pi. So yeah, you should have been using pi over b. And I bet you that's where a lot of you went wrong and thought that these numbers didn't need to change. But if you think about it, it's different than normal. It has to change. So how does it change? Well, b is 2, so you stick a 2 in here. So the new period is pi over 2. And again, people think, well, so shouldn't there be a pi over 2 here? No, the whole thing is pi over 2. So you want half of that. So half of pi over 2 is pi over 4. Another way to think of that is multiply by a half, and you will get pi over 4 and negative pi over 4. All right, how many of you had that right? All right, that's most of you, but about a third of the class is making a mistake there. Okay, this is a little bit of a trickier graphing question. All right, now let's move on to some other stuff you have to know. Well, if you wanted to know, like, what do I have to know for this test? We actually decided to make a list this time because you're coming back from spring break. And you only have 2 days and then a major test. We thought we would do this. We don't normally do this. So I'm going to pause for a second and pull that up. Okay, so there's one of the things you have to do is inverses. You remember all those restrictions? Like, what grows here? Nothing. Nothing goes there. What goes from here to here? Inverse cosine. And the other two, but which one touches here and here? Sine can go from there and there and touches in both spots. And by the way, when I say there and there, I mean pi over 2 and 3 pi over 2, right? No. What's not right? It should be negative pi over 2 right there because these are inverses. So those are some thoughts on inverses. Next, you have to do trig graphing. You'll have to know sine or cosine or tangent. That's like the one we just practiced. Okay? You'll have to do nested inverses where you're going to make the little triangle. And you always, when you have a nested thing like sine of cosine inverse 1/3 or whatever, you always start by drawing a little triangle in there. Okay? And you get the answer for the first inside first. All right, next topic. Solve for multiple frequencies. Basically, that means, do you get how that 4x, I taught you to use a what? A U, what's it called? A U substitution to solve that kind. Okay, the next one, solving for any trig equation, which means, do you know the difference between all solutions or 0 to 2 pi? What's the main thing on all solutions? You got to remember to put plus 2 pi n. All right, good. So these are the hints that we have. If you can get it down to one trig function, notice you don't want like sine and cosine in your equation. You want to get it all to be cosines. Well, how can you do that? You've got this sheet full of identities. And we're going to give you the sheet. So if you saw sine squared, you should be able to go, oh, I know, I could put in 1 minus cosine there. You can find them on the sheet if you have to, but get it down to one trig function. 2 pi k is the way to get all the values. If you divide both sides by a trig function, remember that you're going to lose a solution. Let me show you what I mean by that. Say you had sine x equals sine x cosine x. Do you get you could divide both sides by sine x? It's legal, but you're going to miss out on some solutions. What you have left here is that cosine equals 1. You could solve that and get an answer, but you've lost an answer. What do I mean by that? If you had done it right, you would have moved it all to one side and set it equal to 0 and then factored it. This is one of my practice problems. I'd like you to do that right now. Move it all to one side of the equation so that it's set equal to 0, and then factor it, and then solve both parts, and you'll get lots of answers instead of only 2. You'll have, I believe, 4 answers. But the kid who did that cancel thing I just showed you, they would only get 2 answers. You're going to get either 3 or 4 answers if you do it the right way. Now, it doesn't matter which you move to which side, but I'm curious. How many of you moved this to the left? Raise your hand if you did it that way. How many of you moved this to the right? Okay, that's almost everybody. I'll do that. Now, again, the answer will come out the same, but so it's minus sine x. Anytime you're tempted to cancel something, that means if you rearrange it, you could factor it. That same sign that would have canceled by doing that other technique is going to now factor out. And if this thing equals 0, I could say it on either end. Doesn't matter. I kind of like it on the right. I'm going to now factor out the sine x, and I get cosine x minus 1 equals 0. And now you've got probably 2 answers for that equaling 0, and 2 answers for this equaling 0. Solve this one and solve that one. Sometimes you only get 1 answer, but usually you get 2. See if you get 2 answers for this, sine x equals 0, and 2 answers for this, cosine x minus 1 equals 0. I'll pause where you give that one a try. Okay, so let's talk about these answers. I thought there was probably 4, but maybe 3. And actually, I think there's 3, but 2 of them overlap, which makes it only 2. But we'll show you. Sine of x equals 0. Well, if they say sine of x equals 0, they're really saying y equals 0, because we've learned that sine is pretty much y. It's y over the radius, technically. You're going to learn more about that next. But the radius, when you're in the unit circle, is just 1, and therefore it works out to be sine is y. If sine's y, here's y. Where is y 0? Well, y is equal to 1 here, and y is equal to negative 1 here. So it must be here and here. 0 and pi. Raise your hand if you had those 2 answers. Okay, good. Now, did I ever say to limit it between 0 and 2 pi? Did any of you remember to put plus 2 pi n afterwards? I think the 8 people did. Good job. Okay. The next part, this part, cosine of x minus 1 equals 0. So therefore, cosine of x has to equal 1. And cosine is x, so x equals 1. Where on this thing is x equal to 1? Right there. So the answer is 0 again. So I have 0 and pi and 0, and you don't have to list 0 twice, really. So there's really only 2 answers, 0 and pi. Okay, now what are they? What are they really? If you stick in a 0 here, here, and here, then your answer will be 0. If you stick in a pi here, here, and here, the answer will also be 0. If you think pi doesn't work, or what? Okay. So sine of pi is what? Oh, that's okay. It's all right. So I think, yeah, I hear you. You're thinking, wait a minute, cosine of pi isn't 0, but it's 0 times something makes it 0. So yeah, that's what these are. These are answers. They're what you can stick in for x to make the original equation, which I guess is not technically that, but it's a rewrite of the original equation. It's what makes it true. All right, moving on. We are very close to the end here. No, actually, we're not. It's a different day. We're on math schedule, so good. We have more time. But when we get to the end, you're going to want to know what your homework is. So I'm going to show you right now. I want to know. All right, so here's the ones I think you could skip from the review. You can skip 2A. You can skip 4C and You don't have to do number 6 this hard. We don't need this shift in here. That's going to add a lot of complication. And it would make it way more than 3 minutes. But with it the way it is, it should be more like 3 minutes. So that's about right. Okay, so there's what you should do for homework for tonight. On this slide, I hadn't gotten to this last piece of hints. And that says you can find the values for multiples by setting mx equal to each answer and then solving for x. Do you remember we started with that yesterday? Let's say we had this. This is that kind where you can get multiple answers between 0 and 2 pi. So how do I start with solving this? Because it was a u substitution, and now you just put this 2x back in for u. Because you probably solved it and got u equals that. And then you remembered, oh, that's right, I did a u substitution. So now I got to put back the 2x. How do I do this? Multiply by 1/2 or divide by 2, because you got to get x alone. That's the point of solving, is get the x alone. So multiplying by 1/2, multiply by 1/2, multiply by 1/2. That cancels that cancels that, and that cancels that, and x equals, and then give me all the solutions between 0 and 2 pi. Try it. This is just a solution with a list of other things you could do to get the rest of the solutions. I want to know, what are all the solutions between 0 and 2 pi? Question? You're right. You're right. I implied that those 2's would cancel. You are correct. They would not. So it's 1/2 times pi over 2. I should have just let you do it from there. You can handle it from here. All right. Figure out what x equals, but that just be one of your answers. I want to know how many. There might be 3 answers. There might be 4. There might be only 2. But all the answers between 0 and 2 pi. Anyway. Okay, so you should have gotten x equals pi over 4 plus pi n. Why can't you leave it that way? Because that's all the solutions. Which ones do I want? I want all the solutions that are less than 2 pi, so I got to basically go get a bunch. I start by sticking in integers like 0. So I put in 0, and 0 pi, of course, means I just have pi over 4. Here's my big list. Pi over 4 is one of my answers. Okay, what's another one? I stick in a 1. That's pi. What's pi plus pi over 4? Well, I think of it as 4 pi over 4 plus pi over 4, and that makes 5 pi over 4. All right. Now what if I put in a 2? Instantly I go, I got 2 pi plus something. That's going to be too big. There was only 2 solutions in this case. Raise your hand if you had them right. Okay, good job. All right, so you just keep on putting 0, 1, and 2 into your little equation. All right, so that covers all the topics that it says on the test. I want to do a couple others that just like it referenced vaguely. And I want to do some practices of those kinds of things. Like, for instance, sine of arctan of 1/5. When you have inverses, do you have rules on where you can draw the triangles? Yes, you do. So even though you do a rewrite here, you start on the inside and rewrite this as tangent of some angle equals 1/5. You can't get both answers. You would have normally got 2 answers for this. You don't. You only get 1 because you have to cross off certain quadrants and stuff. Once you find that triangle, draw a triangle as the hint. Then you just got to find sine of that angle of that triangle. Give it a shot. Pause for a second while you do. All right. So you would have started by figuring out where's tangent positive. All students take calc. Tangent's positive here and here. So I'm going to cross these off. All right. Now I'm going to draw my little triangles in there. Wait a minute. Stop. You did 2 answers and you'd be so wrong. Why can't I do that, Mr. L? Very good. Nothing grows in there. Tangent's only allowed from here to here, and it does not touch. Now, it doesn't really matter in this case because we're not on a quadrantal. But if they'd asked you to do this quadrantal right here, you'd have to say, no, I can't do that because tangent doesn't go there. So tangent is 1/5, and that means this is the square root of 26. Do you really need to know that? Yeah, because you're going to then do the sine of this angle right here. And we'll need that hypotenuse. So you'd find that by square root of the other 2 squared and added. Final answer, sine is opposite over hypotenuse, 1/√26. Raise your hand if you had that one right. Okay. All right, next one. Let's try. Square root of 2 sine of 3x equals 1. Who knows the first step? Divide by square root of 2. Next. Who knows the next step? 3x is the pain in the butt, right? U substitution. Get rid of the 3x and just make it easier. Put that in as a u. And let u equal 3x. See if we can figure it out from there. By the way, 1 over square root of 2 is one of those triangles you know. It's 30s, 60s, 90s, or 45s. Pause for a second while you give that one a try. All right, getting into a time crunch, so I'm going to keep, you're probably doing it, but I'll do it with you here. So if I'm going to do this one, I have to find where sine is positive. All students take calc. Can't be there, can't be there. And was this an inverse sine question, so I have more restrictions? Nope. It was not an inverse sine question. Therefore, I can do it in both of those spots. All right. So I get an answer here. Sine is opposite over hypotenuse. Oh yeah, that's the 1, 1 square root of 2 triangle. That's 45. But I shouldn't use 45. I should use what? Pi over 4. All right. So my answer is pi over 4 for that. And then when I go over and do it over here, it's more pi over 4s. How many? 3 pi over 4. And I should say plus 2 pi n plus 2 pi n. And if you see somebody else's say 2 pi k, it's the same thing. Then, am I done? No, because I figured out u. And I really have 3x equals this, and 3x equals that. Now, I'm going to get rid of the 3 by timesing by 1/3 on both sides. I get, this one turns into pi over 3 times 4 is 12, plus 2 pi n over 3. Raise your hand if you had that one right. Okay, good. And this other one, I'm going to multiply by 1/3 on both sides. And that'll make it pi over 4 plus 2 pi n over 3. So there's your two answers. I am not going to go through the process of saying between 0 and 2 pi. If I did, you'd have had to stick in 0, stick in 1, stick in 2, and then keep going until you get answers, all the answers between 0 and 2 pi. Sir? N is an element of z. Yes. All right. That's all I got for you for today. You know what your homework is for tomorrow? Test is tomorrow. Strongly recommend do your homework and check it. Have a great day.